What's up everyone? Welcome back to the channel. In today's video, we're diving into the fascinating world of cybersecurity by exploring how ransomware works and understanding its inner mechanism. Quick disclaimer, before we proceed, this video is for educational purposes only. Many cybersecurity websites provide access to ransomware samples such as LockBit, which security experts like myself use for research and analysis to better understand these threats and effectively respond to incidents. Misusing this knowledge for malicious purposes is illegal and unethical. Always use your skills responsibly. Now, ever wonder how cybercriminals build ransomware? Today, we will dissect the LockBit builder and reveal how it works. Stay tuned because this is an eye-opening breakdown. So, let's jump straight into the LockBit builder directory. Here's what we have. First, we have the build folder. The build folder contains the ransomware files generated by the builder. Currently, this folder is empty because we have not run the build.bat file. Next, we have the build.bat file. This file is responsible for carrying out the build process. We'll explore this file shortly. Next, we have the builder. This creates the actual ransomware payload. Next, we have the config file. This is a JSON file where all the critical settings are adjusted. And then finally, we have the Keygen file. Now, this file is used to generate public and private key pairs rapidly. Now, let's explore the build.bat file. So, once the build.bat file is run, it clears the contents of the build directory to ensure a fresh start. Then, it runs the Keygen, generating the public and private key pairs. These are essential for encryption and decryption. Next, it creates a decryptor for this particular instance of the ransomware. Next, it creates 5 different types of encryptors, including executables and DLL, with some versions even incorporating password protection to add an extra layer of complexity. So at line 5, as you can see, it creates an executable and it dumps it into the build folder. In line 6, it creates another executable, but this time with a password, and dumps it in the build folder. At line 7, it creates a DLL encryptor and puts it in the build folder. At line 8, it creates a DLL version, but this time with a password. And finally, at line 9, it creates a reflective DLL version. Now, at this point in time, you may ask, why create both password protected and DLL versions? This is done for several reasons. One being bypass detection. Security software cannot easily analyze the payload of password protected files, making it harder to detect as malware. Also, controlled execution. The password ensures the ransomware is only activated intentionally by the attacker. LockBit creates a DLL version with password to enhance stealth and flexibility. This approach improves detection evasion. Finally, LockBit creates a reflective DLL to use reflective DLL injection, a technique that hides the ransomware from detection. It allows the malware to load directly in memory without writing to disk, bypassing security measures and blending in with legitimate processes. So, this is how the build process works. Now, let's look at the config.json file. Right off the bat, we have bot information. This is a unique identifier assigned to each user or instance of the ransomware builder. It helps the malware operator to track which user or affiliate is responsible for generating the ransomware. Essentially, this is used for a LockBit affiliate program. Now, on the configuration, the first thing we see here is encrypt mode set to auto. Now, in the LockBit ransomware config.json file, the encrypt mode auto tells the malware to automatically determine which encryption method to use based on the target's system's environment. The ransomware essentially scans the system to decide which encryption algorithm is most effective or compatible with the target's environment. So this could be either AES, RSA, for example. Next, we have impersonation set to true. This allows the ransomware to execute tasks using different user accounts or privileges for great effectiveness. So let's say the attacker had compromised credentials for the entity they want to target. This is set to true, and also those accounts are configured below here. So during the execution, those accounts will be denied. Next, we have skip hidden folders set to false. Now essentially, this is self-explanatory. It is basically asking, do you want to skip hidden folders? Next, we have language check set to false. This allows the ransomware to execute on any system regardless of language or location. Next, we have local disk set to true. Essentially, this is basically saying, do you want to encrypt local disk? Next, we have network shares set to true. Again, this is self-explanatory. Essentially, this is saying, do you want to encrypt network share? Next, it has kill processes. So it kills all the necessary processes. Then it kills all the necessary services. Then we have running one set to true. This ensures that only one instance of the ransomware runs on the target system at a time, preventing duplicate processes. Next, we have print note set to true. This enables the automatic printing of ransom note on a connected printer, aiming to ensure the victim notices the ransom demand. Next, we have set wallpaper equal true. Now, this is self-explanatory. Essentially, what it does is it changes the desktop background. Then we have set icons true. Next, we have send reports set to false. This disables sending reports back to the attacker, such as notifications about successful infections or encryption progress. Next, we have self-destruct set to true. This typically means that the malware is programmed to delete or remove itself after executing its payload. Next, we have kill defender set to true. Essentially, what it does is that it stops Windows Defender. Then we have wipe free space false. Now, this means that the ransomware will not overwrite or erase the free space on the disk. This setting controls whether traces of deleted files in unused disk space are removed to hinder forensic recovery. So, in forensics, there's a concept known as file carving. So, if this particular setting is set to true, it will be difficult to recover any deleted file. Next, we have PS exec net spread false. This means the ransomware will not attempt to spread itself across a network using remote process execution technique. So if you guys are familiar with ransomware, WannaCry used SMB to propagate itself across networks. SMB is a protocol used for network file share. Next, we have GPO net spread set to true. This allows the malware to exploit group policy to propagate itself across a network, bypassing other security measures. This is one method of lateral movement used by attackers within compromised networks. Then we have GPO PS update set to true. Now, this refers to using group policy objects to execute PowerShell scripts for performing tasks like updates or making changes to the infected system or network. Then we have shutdown system set to false. Now, this basically controls whether or not you want the ransomware to shut down the system after compromising any system on the network. Then we have delete event log. This simply means that the malware will attempt to delete system event logs on the infected system. This makes it harder for forensic investigators or incident responders to trace the activities of the ransomware, delaying detection and also response. And then finally, we have GPO delay set to 1. Now, what this means is that after the malware is executed, it will wait for 1 second before attempting to delete or modify the group policy setting on the infected machine. Then we have white folders and a list of white folders to skip over during execution. white files, a list of files to skip over during execution. White extensions, essentially a list of extensions to skip over or do not encrypt these extensions during encryption. And then we have white hosts. So if a particular host on the network is listed here, do not encrypt that host. Now these three lines, white folder, a list of white folders, white files, a list of files, and white extensions are basically configured in the ransomware to allow a system to remain bootable. So here you see the boot INI file listed. Now this is done so that the computer, although it is infected with a ransomware, can still be able to boot. Next we have kill processes, a list of processes to kill. We see things like SQL, Oracle. Now you may wonder, why kill SQL? Why kill Oracle? So for those of you who are familiar with databases, if you encrypt a database while it is running, there is a 99% chance that the file will get corrupted. So in order to prevent the file from being corrupted, the ransomware would kill the process. So scrolling further, you can see a list of additional processes to basically kill during execution. Next, we have kill services and a list of services to kill. Things such as SQL, Microsoft Exchange, Sophos, Veeam, Backup. So essentially what is done is basically the attacker lists all of the services that should be killed during execution. For instance, you see things like Microsoft Exchange, Sophos. This is an endpoint detection tool. Veeam, this deals with backup, etc. Then we have gate URLs. This is used by the malware to communicate with its command and control server or update the malware during the infection. Then we have basically impersonation accounts. This helps the ransomware identify and exploit accounts with elevated privileges, which is a key tactic for maximizing damage. And then finally, we have the note. Essentially, you can change the note to anything you want it to be. So that's it for the config. Now I will actually run the build.bat file to show you what occurs during the build process. Let's get it. And here you have, as you can see, the script was executed successfully. Let's go into the build folder, and these are all of the files. The decryption ID, this is unique for each victim. Then we have the 5 encryptors that were generated. Then we have the LockBit decryptor. So if you ever wonder what it looks like, this is what it looks like. Then we have a password file with information on how to execute the ransomware in safe mode, and also to the actual password that you need to use. So this is the password file, and it also has some information on how to execute the file, etc., and the actual password, and some other examples. And finally, we have the private and public. So that's it for today's video. If you have any questions, leave them in the comments below. Also, if you would like to see a demo of the LockBit ransomware being executed in a sandbox environment and using a decryptor to recover files, let me know in the comments as well. Until then, remember to always use your skills responsibly. See you in the next video.